Lesson 4, Midpoint and Distance in the Coordinate Plane. Your learning targets for this lesson are to develop and apply the formula for midpoint, and then use the distance formula and the Pythagorean theorem to find distance between 2 points. Your vocabulary words are coordinate plane, leg, and hypotenuse. It all starts with a plane. A coordinate plane is a plane that we've divided into 4 regions by a horizontal line, which we call the x-axis, and a vertical line, the y-axis. The location or coordinates of a point are given in an ordered pair, x, y. You can find the midpoint of any segment by using the coordinates of its endpoints. We simply calculate the average of the x-coordinates and the average of the y-coordinates. There's a formula. To find the midpoint on a non-horizontal line, we use M, which is midpoint. You notice it's capitalized, not a small m, like for slope. This would be x1 plus x2 over 2 and y1 plus y2 over 2. The way this works is that we take the x-coordinate from point A and add it to the x-coordinate from point B, divide by 2. Then we take the y-coordinate for point A and we add it to the y-coordinate for point B and divide by 2. If you are given a problem with no illustration, it makes it easier if you draw yourself a picture. Plot the given segment's endpoints on the coordinate plane. Example 1, finding the midpoint. Find the coordinates of the midpoint of PQ with endpoints at P, which is negative 8, 3, and Q, which is at negative 2, 7. First, we have a drawing. We have negative 8, 3. This would be P, and Q is at negative 2, 7. We use the formula. We add the x1 and x2, so negative 8 plus negative 2 over 2, and 3 plus 7. This gives us negative 10 over 2 and positive 10 over 2, which simplify so that the midpoint of the segment is at negative 5, 5. If we count over at negative 5 and go up 5, we can see that this would be the center or the midpoint of our segment. You try. Pause the video recording and work this problem, and I'll give you the answer in a moment. First, you drew a picture, and then you used the midpoint formula. You should have come up with 3 halves, 0. 3 halves would be 1 1/2 and 0. It would be right here, which would be the center of this segment. What if we don't have both endpoints? We're given a midpoint and one endpoint. We can find the coordinate of the other endpoint. M is the midpoint of xy. X has coordinates 2, 7, and M has coordinates 6, 1. Find the coordinates of y. First, let's let the coordinates of y equal x and y. Then we're going to use the midpoint formula. You notice that we set the formula equal to the point in the middle, which is our midpoint that they're given. We substitute in the x and y that we have, so this would be 2 plus x over 2 and 7 plus y over 2. We need to solve for x and y. To find the x and y coordinates, we want to set the coordinates equal, just as we had before. We can do this one at a time. Since x of the midpoint equals 6, we put 2 plus x over 2 equals 6. We have a fraction. we're dividing by 2, so we need to multiply both sides by 2. Simplify. We get 12 equals 2 plus x, and then we have a simple algebra to solve. We'll subtract the 2 from both sides, and we get that x equals 10. We do the same thing for the y-coordinate. We set the 7 plus y over 2 equals to 1. Multiply both sides by 2 again. Simplify. Subtract the 7 from both sides. And y equals -5. So the coordinates of point y are 10, -5. Now you try. Pause the recording and come back when you've finished. We're going to set the coordinates equal. We have -1 as our midpoint for x. So we plug in the x of -6 plus x over 2. And on the other side we have 1 equals -1 plus y. Multiply both sides by 2. Simplify. Add. Simplify again. The coordinates of t are 4, 3. If we want to find distance or the length of a full segment that's not on a horizontal, we use the distance formula. This is d equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. For example, we want to find f and g, fg, and jk. Then we're going to determine whether or not fg and jk are congruent. First, we have to find the coordinates of each point. Then we'll use the distance formula. For fg, we plug in 5 minus 1 and 5 minus 2. We simplify, square our numbers, and take the square root. The length of fg is 5. Let's find the length of jk. We plug in our coordinates, simplify, square the values and add them, and then take the square root. As you can see, we had to simplify. This is not a perfect square. We have 3 square roots of 2. Since 5 and 3 square roots of 2 are not equal to each other, that means that fg and jk are not congruent. Pause the video and give it a try. Using the distance formula, we plug in the coordinates for EF, simplify, square our numbers and add them together, and EF is 5. We do the same for GH. We put in our coordinates, simplify, square and add, take the square root, and EF and GH are the same because they both equal 5. Let's look at some other definitions. In a right triangle, the two sides that form the right angle are the legs. The side across from that angle that stretches from one leg to the other is the hypotenuse. In the diagram, A and B are the lengths of the shorter sides, or legs, of the right triangle, and the longest side is called the hypotenuse and has length C. You can see that it is directly across from the right angle. Another way to find distance is to use the Pythagorean theorem. We can use this by constructing a right triangle on a coordinate plane. In a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. Or as we've seen it before, a squared plus b squared equals c squared. Let's use this. Use the distance formula and the Pythagorean theorem to find the distance to the nearest tenth from D to E. First, we'll use the distance formula. We'll plug in our numbers, simplify, square and add, and then we'll simplify again. And we get 10.3. So DE is 10.3. If we use the Pythagorean theorem, we'll count the units to find A and B. You simply count from point E to point C. So 1, 2, 3, 4, 5 for A, and 1, 2, 3, 4, 5, 6, 7, 8, 9 for B. And then we plug these into our formula. C squared equals A squared plus B squared. So A is 5, we square that and add it to 9 squared. 25 plus 81. This is 106. Remember, this is C squared. We want to know what C equals. So we have to take the square root, which gives us 10.3, just like the distance formula. You try it. Pause the video and work out the problem. Method 1, I use the distance formula. We find the coordinates for RS and plug them in, simplify, and we get 6.7. Method 2, we count the units for A and B. A is 6, B is 3. We use the Pythagorean theorem, and we end up with 6.7. Let's look at an example of a sports application. The player throws the ball from first base, right here, to a point located between third base and home, 10 feet from third base. If we count, we have 10, 20, 30, 40, 50, 60, 70, 80, 90. So 10 feet would be here at 0, 8, 80. So from here to here. We want to know the distance of the throw to the nearest tenth. We set the field up on a coordinate plane. We have our coordinates for each base, and the target point, like we said, was at 0, 80. The distance of the throw will be FP. So it's going to be the beginning place, which is at first base, and it's going to 0, 80. So we have 0 minus 90 plus 80 minus 0 squared. This gives us a ginormous number, but when we simplify it, we get 120.4 feet. The center of the pitching mound has coordinates 42.8, 42.8. That would be right here. When a pitcher throws the ball from the center of the mound to home plate, what is the distance? So from the center of the mound to home plate. So we want the midpoint of this line segment. We look at 0, 0, and this. We can just use the distance formula here. 42.8 minus 0 and 42.8 minus 0. We square those numbers and add them and take the square root. It is exactly 60.5 feet. Make sure that you have written your notes carefully and are ready for next class period. Have a good evening.